Hey, welcome back. Today's video is a little different. There is no coding at all. Today we just learn the words. Here is the thing. When people talk about AI, they throw around very scary words. Tensors, epochs, laws, training, and it makes it all sound way harder than it is actually. But every one of these words is a simple idea, wearing a fancy costume. So in this video, I am going to take off the costumes. I'll explain every word in plain English using an example anyone can picture. If you can imagine a spreadsheet, you are ready. Let's go. Before we start, let me give you one example that we'll use for the entire video. Imagine we want to build an application that looks at a photo and tells us, is this a cat or a dog? That's the whole thing. Simple, right? Every single word I'm about to teach you, data, model, training, all of it is just a piece of how an application learned to do this one job. So whenever a word feels abstract, just come back to this. Cat or dog? Keep that picture in your head and everything else click. Okay, the big picture first. Every AI model, no matter how fancy, works like this. Something goes in, the model thinks about it, and an answer comes out. For us, a pet photo goes in. The model, the smart part, looks at it and out comes the answer. It's a cat. Input, model, output. That's the shape of everything. And honestly, as an Android developer, you already know this shape. It's just a function, bro. You give it something, it gives you something back. You have written 1,000 of functions. This is one more. So let's discuss the part one, the data. This is the part that looks scariest because it shows up as a wall of numbers. But I promise it's a simple thing in the world. It's just examples. Think of it like a folder full of flashcards. Let's break it down. Word number one. Dataset. Don't overthink this one. A dataset is just a big collection of example. That's it. For our cat or dog application, the dataset is a folder of say 1,000 pet photos, half cats, half dogs, where each photo already has the right answer written on it. Think of it like a stack of flashcards. Picture on the front, answers on the back. Where do you use it? It's always step one. Before an app can learn anything, you need examples to show it. In Kotlin term, it's just a list of items, nothing you haven't handled before. Word 2, and these two go together, features and labels. You will see them written as X and Y, and they scare people for literally no reason. Go back to the flashcard. The front of the card is the picture, that's the feature. The X, it's what you show the application. The back of the card is the answer. At, that's the label. The Y, that's the whole idea. X is the question, Y is the answer. In Kotlin, X is the thing you pass into the function, Y is what it returns. Question in, answers out. So next time you see X and Y, just think front of the card, back of the card. Word 3, the training set and the test set. Simple idea. You take your flashcard and split them into two piles. The big pile, say 800 photos, is the training set. That's what the application studied from. The small pile, the other 200, is the test set. You hide those away. After the application has studied, you give it those hidden photos at the surprise quiz. Why hide them? Because if you quiz it on the same photos it studies, it can just memorize the answer and look smart. The hidden quiz prove it's actually learned. It's exactly like studying with some flashcards and being tested on new ones. This is the slide that scares people. So let's kill the fear right now. When you open up the data, you see a giant grid of numbers. It looks like a matrix. It is not. Here's what happening. A computer cannot actually see a picture. So we turn each photo into a row of numbers. One number per pixel. One photo becomes one row. Stack all the rows up and you have got the table. A spreadsheet. On the left, the answer, cat or dog. On the right, the photos as numbers. That's all the data is. A spreadsheet where each row is one example. You have built tables before. This is just a table. Word 4, tensor. This sounds like something from a physics class, but it is the easiest word here. A tensor is just a box of number and its shape just tells you how your numbers are arranged. Look at this. One dimension is a simple list. Two dimension is a table. That's our photos, rows and columns. Three dimension is like a spreadsheet with several tabs, a stack of tables. And four dimension is just many photos at once, a whole batch. More dimension just means more nesting, a list inside a list inside a list. So when someone says tensor, just hear box of numbers. When they say here how it's arranged, that's it. Word 5, sparse. People freeze up at this word, but it's very tiny. There are two ways to write down an answer like that. The first way, sparse. Sparse is just a number. Cat is 0, dog is 1, bird is 2. Nice and very short. The second way is one hot. One hot is a row of yes or no boxes with a single yes. Cat is 100, dog is 010. Sparse just means I'm using the short number version. In Kotlin, sparse is like an enum numbers and one hot is like a row of true and false flags. Same answer, just written two different ways, and you will spot the word sparse in the setting that expect the number version. Word 6 is only for when your input is words instead of pictures, but you'll hear it a lot of times. So let's cover it. Computer cannot read words, it can only count. So the first thing we do is swap each word for a number. Good becomes 7, little become 2, dog become 15. That's swapping is called tokenization. Then there's padding. Sentences are different length, but the application wants every input the same size. So we just add zeros at the front to fill the gap until they all match. That is padding. Swap words for numbers, then pad them to equal length. Simple as that. Word 7. Normalization. Fancy word, very tiny idea. It just means shrinking big numbers down to small, tidy ones. Here is the example. A pixel's brightness goes from 0 all the way up to 255. Those are big, messy numbers. So we just divide them down so they land nicely between 0 to 1. The question is why we do it. Because small even number are way easier for the application to learn from. Big wild numbers throw it off. That's it. Normalization is just adding up your numbers before handling them over. Now we're gonna jump into our part 2, which is the model. This is the brain of the application, and you'll see it not a magic. It's just a stack of small steps, each doing a little bit of the work. Let's open it up. Word 8. Models and layers. A model is just a stack of steps, one after another. Each step is called a layer, and each one spots a little more than the last. Picture our dog application. The photo goes in the top. Step 1 spots simple edges and lines. Step 2 builds on that and spots shapes like ears and eyes. Step 3 look at all of it and makes a final call. Cat or dog. Photo in the top, answer out the bottom with a few steps in between. That is the model. It's not one big magic box, it's a little assembly line. Word 9. Weights. This is the one word that actually is the important stuff. Weights are the number the application learns. Think of them like tiny knobs. During learning, the application keeps tweaking these knobs until it gets cat and dog right. When people say a model learned, they literally mean it found good settings for those knobs. And that model file you drop into your application, it's basically a big list of these learned numbers. On the phone, they are logged in. They never change. Your application just read them to make predictions. So weight are the app's memory, the stuff it figured out during training. Word 10. Neuron and dense layers. Don't let neuron fool you. It's not some brain science thing. A neuron is just one tiny helper that takes a few numbers, does a quick calculation, and passes the answer along. One small worker. A dense layer is just the whole row of those little workers standing side by side, all doing their bit. It's the most common building block you will see. So a neuron is one worker, a dense layer is a team of them. That's the whole thing. Word 11. Activation. This sounds technical, but here is the plain version. It's a little helper attached to each step that lets the application learn tricky, curvy patterns instead of only straight things. Cats and dogs aren't a straight line problem, so we did this. You'll mostly see two names. ReLU is used in the middle step. Its rule is simple. Keep the useful signals, ignore the rest. And sigmoid is used right at the end. It turns the final result into a confidence like 90% sure it's a dog. You don't have to understand the math, just know ReLU in the middle, sigmoid at the end. That's the usual recipe. Word 12. Embedding. This one's for the text applications, and it's a lovely little idea. A word on its own, like the number 15, means nothing. And embedding gives each word a small set of numbers, like a fingerprint that stands for its meaning. The neat part, similar word get similar fingerprints. So cat and kitten end up close together like neighbors, while car is way over on the other side. The app figures this out on its own. You only meet embedding when your application works with words instead of pictures. It's usually the very first step there. Think of it as a lookup table of meaning that the application builds itself. Now we're gonna start the part 3, which is training, which just means teaching the application. This is where it actually learns from all those flashcards. We'll cover the difference between teaching it and using it. That's the big one for Android developer, and then the simple words for how it practices and how we grade it. Word 13, and this is the most important one for you as an Android developer. Training versus inference. They sound similar, but they are totally different. Training is teaching, showing the application all those flashcards until it learns. It's slow and heavy, and it happens once on a big computer before your application ever ships. Inference is just using the trained application, showing it one new photo and getting one answer. It's fast and light. And here's the key point. Your Android application never trains. It only ever uses the finished model. Training is a school. Using it is the real job. Your phone only shows up for the real job. Word 14, epochs and batches. These just describe how the application studies its flashcards. An epoch is one full pass through the whole stack. So 5 epochs simply means it went through all the flashcards 5 times, getting a bit better each round, just like reviewing your notes a few times before an exam. A batch is how many cards it looks at before it learns a little. It does not cram all 1000 at once. It studies in small handfuls, maybe 32 at a time. That's it. Epoch, how many times it reviews everything. Batch, how big a handful it takes each time. Word 15, loss. Great word. Simple meaning. Loss is just a score for how wrong the application is. That's all. The best way to picture it is golf. Lower is better. A big loss means it's guessing badly. A small loss means it's doing great. And the entire point of training is to push that number down. So while the app studies, you watch the loss drop lower and lower. And that falling number is your proof that it's actually learning. So loss represent a wrongness score and lower is very better. Word 16, the optimizer. If loss is a score, the optimizer is a coach. It looks at each mistake and tells the application how to fix it and do better next time. The one you'll see everywhere is called Adam. It's smart, big correction when the application is way off. Tiny tweaks as it gets close. It's the reliable default. You rarely need anything else. There is also the learning rate, which is just how big each fix is. Too big and it overshoots. Too small and it takes forever. Good news, Adam mostly handle that for you. Picture learning to shoot basketball. Miss badly, big adjustment. Nearly there, very tiny tweak. That's the coach at work. Word 17 is accuracy. This is the friendly number, the one you actually care about. Accuracy just means out of 100 guesses, how many did it get right? If our cat or dog application scored 94% on that surprise quiz, it means it correctly labeled 94 out of every 100 photos it had never seen. Remember loss? Loss is the technical score the machine uses. Accuracy is the human-friendly score for you. And unlike loss, higher is better. So when someone says the model is 94% accurate, now you know exactly what they mean. And our 18th word is overfitting and underfitting. The two ways learning goes wrong. Overfitting is a sneaky one. The application memorizes the exact study photos instead of learning what a cat actually look like. So it aces the ones it studies. But the moment you show it new cat, it lost. It's like a student who crammed last year's exam word by word, then panic when this year's question are different. Underfitting is the totally opposite. It barely learned anything, so it's bad on everything. Study photos and quiz alike. That's just not studying enough. What you want is the sweet spot in the middle. It learned the real idea of cat, not just the photos it saw. Now we're gonna jump into our part 4, the home stretch. A few handy extra words. Those come up all the time and they are each a one-liner. Two kind of questions AI can answer: how to borrow a ready-made model and how we shrink models down to fit on a phone. Word 19, classification versus regression. This just split AI problem into two types based on the answer. Classification picks a category. The question is which one, cat or dog, spam or not, good review or bad. Our whole app is classification. Regression predicts a number instead. The question is how much, price of a house, tomorrow's temperature, how many minutes late your delivery is. Easy way to remember. Classification give you a category like picking from an enum. Regression gives you a number like a float. Which one versus how much. Word 20, pre-trained models. This is the shortcut that makes life easy. A pre-trained model is one that somebody else already trained on a giant pile of data. You do not do any of the learning. You just download the finished model and start using of it. We actually did this in an earlier episode. The image model we dropped into the application was pre-trained. We did not teach it anything. We just reuse someone else's hard work. In Kotlin terms, it's exactly like adding a library through Gradle instead of writing the whole thing yourself. Why build from scratch when you can stand on someone else's shoulders? Last word, number 21. Quantizing. On a phone, size matters. You want a small, fast file. Quantizing is just shrinking the model down. It stores the number a little more roughly, which makes the file much smaller and faster while barely losing any accuracy. The perfect comparison is a photo. The full size version is the sharpest but heavy. Save it as a smaller JPEG and it's way lighter. And honestly, you can barely tell the difference. On a phone, that trade is almost always worth it. Quantizing means shrinking the model to fit nicely on a phone. Let's put it all together using only words you now understand. You start with data, flashcard, each a photo with its answer. You build a model, a stack of simple steps. You train it, it studies, get a score and improves. You shrink it so it fits on a phone and finally it lives in your application, giving answer on every tab. Look at the whole line a minute ago. Half of this word probably felt scary. Now you know every single one. That's the entire journey of an AI model and you have got it. If you forget everything else, keep this 12. Dataset, the examples, feature and labels, the photo and the answer. Train and test, study and quiz. Tensor, a box of number. Model, the stack of step. Weight, what it learned. Training versus using. Teaching it once, then use it. Epoch, one full study round. Loss, how wrong like golf. Optimizer, the coach. Accuracy, how many it got right. And overfitting, it memorized instead of learning. Take a screenshot of this. These 12 unlock almost every AI video you will ever watch. And that's it. You get it now. Every scary word we stand with, tensor, epoch, loss, quantizing, you can hear them in any video now and just nod along. That's the real milestone and it makes everything after this so much easier. Coming up next, we finally get hand-on. We head into Google Colab and build and train our own model step by step. Now that you know all the words, it's going to feel very easy. If this video made things click for you, hit like, subscribe so you do not miss the next one. And tell me in the comments which word finally made sense. See you there.